Next is polarity in covalent bond. Polarity in covalent bond. When a covalent bond is formed between two heteroatoms, the electron pair is not equally shared by both of the atom. Okay. The bonded electron pair is drawn more towards the more electronegativity atom, which develops some partial negative charge on it. The same amount of partial positive charge also accumulates on the less negativity atom. Thus, the bond becomes polar. Such as bond is called polar covalent bond. Example, HCl, hydrogen chloride, that is a H bond Cl. H bond Cl, sigma bond positive and sigma bond negative. The magnitude of sigma is less than 1. The magnitude of sigma is less than 1. If the bond is found between two similar or homonuclear atoms, the covalent bond is nonpolar. In H2O2Cl2 N2 etc. The magnitude of sigma is less 1. If the bond found between two similar homonuclear atoms, if the bond is formed between two similar or homonuclear atoms, the covalent bond is nonpolar. The covalent bond is nonpolar. The covalent bond is nonpolar. As example, H2O2 Cl2 N2 etc. Okay. When a covalent bond is formed between two heteroatoms, the electron pair is not equally shared by both of the atoms. The bonded electron pair is drawn more towards the more electronegativity atom, which develops same partial negative charge on it. The same amount of partial positive charge also accumulates on the less negative atom. Thus, the bond becomes polar. Such as bond is called polar covalent bond. HCl, as an example, HCl, hydrogen chloride bond. Okay, sigma positive, sigma negative. The magnitude of sigma is less than 1. If the bond is found between two similar or homonuclear atoms, the covalent bond is non-polar. As an example, H2O2Cl2 N2 etc. The molecules having polar covalent bond is known as polar covalent bond compound H2O NH3. The molecule having polar covalent bond, those molecules having polar covalent bond is known as polar covalent compounds. Polar covalent compounds, as example, H2O ammonia, water and ammonia, etc. Okay. Polarity is a vector quantity. It has both direction and magnitude. If a bond has polarity opposite to another, the compound will be less polar or non-polar. For example, in carbon dioxide, the carbon-oxygen bond is polar, but due to linear structure of carbon dioxide, the polarity of one carbon-oxygen bond is exactly counterbalanced by the polarity of another carbon-oxygen bond. Thus, carbon dioxide is non-polar, though it contains polar bond. Okay? oxygen double bond, carbon double bond, oxygen, non-polar. That is non-polar. That is non-polar plus minus sigma bond plus sigma minus sigma. Okay. Polarity is a vector quantity. It has bond direction and magnitude. If a bond has polarity opposite to another, the compound will be less polar or non-polar. For example, in carbon dioxide, the carbon-oxygen bond is polar, but due to linear structure of carbon dioxide, the polarity of one carbon-oxygen bond is counterbalanced by the polarity of another carbon-oxygen bond. Thus, carbon dioxide is non-polar, though it contains polar bond. Okay. Next is determination of percentage ionic character. 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 From dipole moment. First is from dipole moment and second is from electronegativity. Okay. Then we will be know about from dipole moment. Of polar molecules, example HCl, hydrogen chloride, HBr, hydrogen bromide, etc. has two polar ends and is known as dipole. The degree of polarity in a polar molecule is expressed in terms of dipole moment. It is denoted by mu. Okay. Of polar molecules, example hydrogen chloride, hydrogen bromide, etc. has two polar ends and is known as dipole. The degree of polarity in a polar molecule is expressed in the term of dipole moment, and it is denoted by mu. Mu is dipole moment. Okay. The product of the change and the distance between the two charge ends is called dipole moment. Okay. Dipole moment mu equal to charge E multiply distance d. Okay. E is magnitude of separated charge. Magnitude of separated charge ESU. Magnitude of separated charge ESU, and D is internuclear distance. Internuclear distance. That is centimeter. That is in centimeter. Okay. Since the charge of the electron E is 4.8 into 10 to the power minus 10 ESU, and the internuclear distance in the order of 10 to the power minus 8 centimeter, then mu equal to 4.8 into 10 to the power minus 10 ESU multiplied 10 to the power minus 8 centimeter. That is 4.8 into 10 to the power minus 10 ESUCM. That is 4.8 D. 4.8 D. D is dB. 4.8 dB. D is dB equal to 10 to the power minus 18 ESUCM. Hence, the unit of dipole of moment mu is called dB. It is a vector quantity and has zero value when the effect of one dipole cancels the effect of the other dipole. Example, in carbon dioxide, the water, ammonia, etc. have definite dipole moment value as 1.71 dB and 1.41 dB. Percentage ionic character from dipole moment. Next is percentage ionic character. Next is percentage ionic character. Percentage ionic character from dipole moment. Percentage ionic character from dipole moment. Okay. The most important application of dipole moment measurement is determination of percentage ionic character. It represents the extent to which a bond is permanently polarized. By measuring the value of mu, the percentage ionic or covalent character in a bond is determined. The bond energy in hydrogen chloride molecule mu calorie HCl hydrogen chloride is a 4.8 into 10 to the power minus 10 multiply 1.27 multiply 10 to the power minus 10 ESU centimeter. That is also converted in 6.09 into 10 to the power minus 18 is equal to 6.09 dB. This is dB. But experimentally observed value of HCl is mu observation is but experimentally observed value of HCl is 1.03 dB. Okay. Percentage ionic character, that is percentage ionic character of HCl is mu observation upon mu calorie equal to into 100 equal to 1.03 upon 6.09 into 100, that is 16.912, that is approximately 70%. Okay. Hence HCl is a 17% ionic, 70% ionic and 83% covalent. Thus the percentage ionic character is given by the following expression. Percentage ionic character is mu observed upon mu calculated multiply 100. Okay. As example, in HCl molecules, the bond distance is in HCl molecules. Example. In HCl molecule, the bond distance D equal to 1.275 angstrom. Okay, and observed dipole moment value is observed dipole moment is 1.03 dB. Then calculated the percentage ionic character. Calculate percentage ionic character. Okay. In hydrogen chloride molecules solution If HCl molecule ionizes, then the charge on hydrogen is 4.8 into 10 to the power minus 10 ESU, and chlorine is minus 4.8 into 10 to the power minus 10 ESU. Okay. Then dipole moment equal to Q multiply D equal to 4.8 into 10 to the power minus 10 multiply D is 1.275 into 10 to the power minus 8 ESUCM, that is 6.12 into 10 to the power minus 18 10 to the power minus 18 ESU centimeter, that is 6.12 dB. 6.12 dB percentage ionic character. Percentage ionic character is mu observation upon mu calculated multiply 100, that is 1.03 upon 6.12 multiply 100, that is 16.83%, approximately 70%. Second is from electronegativity. One minute. Two, from electronegativity. Electronegativity. Pauling proposed a rule which predicts the nature of AB bond in AB molecules with the help of electronegativity value of A and B atoms. According to Pauling, if the difference between electronegativity value of two atoms is 1.7, then the bond will be 50% ionic and 50% covalent. Okay? According to Pauling, if the difference between electronegativity value, if the difference between electronegativity values electronegativities values if the difference between electronegativity values of two atoms is 1.7, then the bond will be 50%, then the bond will be 50% ionic and 50% covalent. If the difference is less than, if the difference is less than, if the difference is less than 1.7, then the value of ionic character will be less. Then the value of ionic character is less is less, and if the difference is and if the difference is greater than 1.7, then the value of ionic character will be more than 50. Then the value of ionic character, then the value of ionic character will be more than 50%, will be more than 50%. The prediction of percentage ionic character upon nature of a bond in every molecule can be given with the help of electronegativity value of A and B atoms as follows. First point, when psi A equal to psi B or psi A minus psi A minus psi B is 0, then the AB bond is non-polar. Then AB bond is non-polar. AB bond is non-polar. Second point, when psi A minus psi B is 1.7, then AB bond is 50% ionic, and 50% covalent. Okay. Third point, when chi A minus chi B is less than 1.7, then ionic character of every bond is less than 50%. Ionic character is less than 50%. Ionic character less than 50%. Whereas covalent character is more than 50%. Whereas covalent character is more than 50%. Fourth point, when chi A minus chi B is greater than 1.7, the amount of ionic character every bond is more than 50%, covalent bond is less than 50%. Then 1.7, then amount of ionic character is more than 50%. Is more than 50%, and covalent bond is less than 50%, and covalent bond less than 50%. According to pooling, percentage ionic character, percentage ionic character, percentage ionic character is 1 minus e to the power minus 1 by 4 chi A minus chi B power whole square multiply 100. Where is chi A electronegativity of atom? Where is chi A is electronegativity of atom A, and chi B is electronegativity of atom B. Okay. Then however, polling rule is valid in certain cases only. Haney and Smith have revised the polling expression is below. But polling rule is valid of certain cases only. Henny and Smith. Henny and Smith have revised the Polling's equations as below. Percentage ionic character is 100, 0.16 chi A minus chi B plus 0.035 chi A minus chi B whole square. Chi A minus chi B whole square equal to 16 chi A minus chi B plus 3.5 chi A minus chi B whole square. Okay. Next is a weak interaction. V2H